Section 2.1.3 Preventing ego from penetrating objects. Another thing left for implementation is the impenetrability of the virtual lab's static objects by ego, that is, the furniture, such as benches, stools, and the walls. For the furniture to be impenetrable, not only ego, but each piece of furniture too needs to have a collider and a rigid body. Walls' impenetrability is implemented in the same manner, with the exception that their game objects do not need to have rigid body components. We will show this implementation through the example of main bench 1 game object mentioned in section 1. Main bench 1 has a box collider with default values and our default material as material. It also has a rigid body component in which, like in ego game object's rigid body, use gravity option is false, while the freeze position and freeze rotation constraints are all false. Furthermore, the is kinematic option is true since main bench 1 is not movable, while interpolate is known and collision detection is discrete, which is also the case for ego's rigid body, as this is the most efficient way to handle the collision between them. Keep also in mind that the tag and layer attributes in the inspector have the values of bench and furniture respectively. Regarding the default material, it has been defined with specific properties which, apart from contributing to the impenetrability of static objects, they also prevent the friction between them and ego, as well as the latter's bouncing. Nevertheless, those attributes do not suffice for static objects to be realistically impenetrable by ego. Instead, we need to make use of ego controller script 2. So, what we have to do is to use the onCollisionEnder Unity's embedded function. Furniture layer and walls layer, which we see in the if clause, have been defined as integer constants in our script and have the values of 11 and 12 respectively. Those values correspond to the numerical values that the layers of the same names have in the layers hierarchy in the Unity editor. So we see in the inspector that furniture and walls occupy the 11th and 12th positions in the layers list respectively. Now let's get back to our onCollisionEnder function. When ego collides with a game object whose layer has the value of furniture or walls, then the velocity of its rigid body becomes 0, that is, it stops moving. Also, a global Boolean variable halt, initialized in start function as false, becomes true. And finally, an I enumerator called unhalting, responsible for the unhalting of ego as its name suggests, is being called. With the help of halt variable, we also restructure our code a bit in the update function by letting the move horizontally and move vertically variables read the key inputs in the horizontal or the vertical axis respectively, only if halt is false. As for the unhalting I enumerator, it simply waits for a WASD or arrow key to be pressed before it sets halt's value back to false and renders ego movable again. This way, in case a game object of a piece of furniture or a wall still resides in ego's collider territory, ego is being halted and therefore is unable to penetrate the other game object due to the former's inertia until a movement key is pressed. Then, depending on the direction of the movement that the key suggests, that is, into or away from the other game object, Unity Physics Engine either blocks or allows RB move position in update function to be executed. Finally, we use onCollisionExit function to secure that when ego stops colliding with a piece of furniture or a wall, that is, the latter's game object just exited ego's collider area, halt variable becomes false no matter what, allowing ego to move again inside the scene. Now, let's test the code we have just demonstrated. In the Unity editor, we press play, and now we will try to penetrate the bench with ego character. We move the ego character forward, and we see that we can't penetrate the bench. So our code works fine.